Alright, today we're going to be talking about the thought process of programming. So you want to, when you're looking at programming something, you want to program something that you do often, that you're going to repeat or you are repeating. If you're doing, for example, the area of circles in class today, then maybe programming the area of a circle so that you don't have to keep doing the exact same pattern again and again and again. So it's something you're going to be doing often or repeating. And then when you program something, you don't want it to be too simple. You want to, the action that you're programming is you don't have to do the work anymore, the calculator has to do the work. So you don't want to make the calculator do work that would actually be faster, more efficient for you to do. So you want to have the calculator do things that are too complex, quote unquote, for you. So you don't want to do 2 plus 2 because it would be easier to do that on your head, on your fingers, on a piece of paper. Type in 2 plus 2 to the calculator instead of making a program, troubleshooting it, and then using the program every time you want to add 2 plus 2. So you want it to be multiple steps, something that's going to repeat, something you're going to be doing often. So like equations or formulas, things that are complex. Think of Pythagorean theorem, quadratic equations, area of a circle, volume of a circle, and then we're going to be doing point slope today, so point slope. And if you think about programming as an investment of your time, you're spending time now so that you can spend less time later. And if you think about it like that, ask yourself, is the time that I'm going to be saving later worth the time that I'm going to be saving now? Or energy, or the things that I have to learn, things like that. Great, we have the thought process out of the way. So with point slope, we're going to run through what this means here in a bit. But what you want to do is have your checklist, right, of the things that you want it to do. And typically across most programs, you want it to ask for the input, to run the calculations, and then display the output, which I can't think of a single program that I've made that doesn't follow this type of pattern. But maybe there might be one that you might make that breaks this pattern. Doesn't matter. This is this typical pattern that programs follow. So let's go back to what I was looking at before. So for the finding the line that goes to the 2 points, if you're looking at this as the problem that you've been given, then you got to look at how to standardize it, how to put it in variables, not in numbers, but in the letters that represent the numbers. So you have your x and your y, your h and your k, and then the first thing you got to do is find m, and then you write out what m is actually equal to, and then you got to find b, write out what b is actually equal to. So m is equal to the rise over the run, right? That's the y over the x. You have the change in how much rise is happening and the change in how much x is happening, and this gives you the amount of change over the entire slope that is happening. So you have your b, which is the intercept. So that's the point at which the graph, the slope, hits or connects with the y-axis, which is the one that goes up and down. And that's how you get this. So you just take the mx over here, and you move it from one side to the other, and that's how you get your y minus mx is equal to b. Okay, so if we're actually going to be programming this, we got to put it into the programmer speak now. We got to put it into computer speak. Oop, not onput, input. There we go. So the command input saves you a lot of effort, because there are other ways that you can get input into the calculator, but input allows you to have the calculator ask you what a specific variable does, or what it is. So if you have x1 is equal to, and then you have it in parentheses, this will display whatever's in the quotations on your screen, and then it'll give you a little box to respond. So you'll be able to put in 5. But we don't want to put in 5, we want to put in whatever, a variable, right? Because we're dealing with variables. We don't want any numbers here, we want it to all be variables. So then whatever number you put in, it'll save it as x. So if I write, display x, not the question mark, display x, it'll display whatever we put in as x, right? But we're not just trying to input display, right? We're actually trying to make the program. So just as a breakdown, this is the whole write-up. We got to change what y1, x2, and y2 so that we know this is the first input. Okay, this is the first input. Okay, this is the second set of inputs. This is the second set of inputs. And then you got to save them to different variables. And when you do that, then that allows you to call on different variables. And if it's all the same variable, it's just going to rewrite. It's not going to be useful. So down here, this is the same thing we had up here. Same exact copied, it's just with the different variables. So this is our m right here. And this little arrow here is the store function, right? And it looks like, on your calculator, it looks like STO, and then it has an arrow. And that way we know, or you're telling the computer, telling the calculator, look, whatever this number, what this is equal to numerically, number-wise, you're going to make that m. So if you had it, again, display m, which we actually do, but if you have it display m here, it'll show you the number that this is equal to. Same thing with b. It's just the little arrow thing makes it equal to. The equal sign, when used out of this context, is a logic gate, and it tests. It's making sure that things are equal to. Here we're telling it, make this equal to. It's a command, not a test. Great. So then we want to show what m and show what b are equal to. And if, like I said before, with the input, if you put it in quotations, it'll show the letters and it'll show the symbols. It won't show the numbers. So if you put the m here in quotes, it'll show the letter m. If you leave the m out of quotes, it'll show you what the variable m is equal to. Great. So if you put this and just this into your calculator, boom, this will work. That, hands down, you can click away now, it works. If, however, you want to become more efficient, if you want to make this more efficient, faster, easier to write, shorter, not as many lines, you can rewrite it all as this. And this has every single component that's exactly the same. It's just written much more efficiently. So what you change is you put these two on the same line. So you just move this up here, and then you rewrite m, and you just copy paste this instead of m. Same thing with here. Copy paste this instead of b. And then all of these commands you can just simplify into one by copying pasting all of these after this, because it's the one input command. It'll still ask the same questions and it's still looking for inputs. That's all it does, is it takes text, it displays the text, whatever your input is after the text, it saves it as a variable, and it moves on. So that's pretty much it. Like and subscribe. I'll be doing other stuff very similar to this with the quadratic equation, maybe some circle stuff, Pythagorean theorem, and I'll eventually probably get into the other uses of these different functions and whatnot. So if you have any questions, don't be afraid to ask them. Suggestions, you ask them in the comments. Like I said, like and subscribe, and you guys have a great day.